Hello everyone. Welcome back to the channel. Today, we are going to talk about a fundamental concept in programming called Object-Oriented Programming, or OOP. This concept forms the backbone of almost every modern programming language, including C++, Java, C#, Python, and JavaScript. Understanding OOP is essential not only for beginners but also for experienced programmers, as it helps in building software that is structured, maintainable, and scalable. In this lecture, we will cover what OOP is, why it is important, its key principles, and real-world examples to make the concept easy to understand. What is object-oriented programming? Object-oriented programming is a programming paradigm that models real-world entities as objects. An object represents a specific instance of a class and has properties, also called attributes or data members, and behaviors, also called methods or functions. For example, consider a car. A car has properties like color, brand, and speed, and it has behaviors such as start, stop, accelerate, and brake. In OOP, the car itself can be represented as a class, and each real car in the world is an object of that class. Unlike procedural programming, which focuses on sequences of instructions, OOP focuses on objects, which makes programming more intuitive, modular, and closer to how we think about the real world. Why do we need object-oriented programming? Before OOP became popular, programmers used procedural programming, where code was written as a sequence of instructions or functions. While procedural programming works fine for small programs, it becomes very difficult to manage as programs grow larger and more complex. Large software projects often suffered from code duplication, difficulty in debugging, poor maintainability, and lack of security. Object-oriented programming was developed to overcome these limitations. By using OOP, we can structure software around objects that model real-world entities, making code more reusable, organized, and easier to maintain. OOP also provides data protection and encapsulation, which enhances security and reduces the chance of errors. Real-world example of OOP. To understand OOP better, let's look at a real-world example. Imagine a student. A student has attributes such as name, age, and roll number, and behaviors like study, take an exam, and submit homework. In object-oriented programming, we can create a student class with these attributes and behaviors. Each actual student, like Ravi or Sita, becomes an object of this class, holding specific data such as Ravi's age or Sita's roll number. This approach allows us to model real-world entities and their interactions in software, making programs easier to conceptualize and maintain. Key components of OOP object-oriented programming revolves around four main components: classes, objects, attributes, and methods. A class is a blueprint that defines what properties and behaviors its objects will have. It is similar to a house plan. The plan itself is not a house, but you can build multiple houses from it. An object is a specific instance of a class, representing a real entity in memory. For example, two students, Ravi and Sita, can both be objects of the student class but will hold different data. Attributes are the data stored within an object, such as name, age, and marks for a student. Methods define what an object can do, like study, or submit homework. By combining these components, OOP allows us to design software that is modular, flexible, and aligned with real-world concepts. Four pillars of OOP object-oriented programming is based on four key principles: encapsulation, abstraction, inheritance, and polymorphism. These pillars make OOP a powerful tool for designing software. Encapsulation refers to bundling data and methods together within a class while restricting access to the internal details. Think of it like a capsule containing medicine. The inner ingredients are hidden, but the user can interact with the capsule safely. In programming, encapsulation ensures that data is accessed only through defined methods, which improves security and reduces errors. Abstraction means showing only the necessary details while hiding the internal implementation. For instance, when you drive a car, you know how to operate the steering wheel, brakes, and accelerator, but you don't need to understand how the engine works. Similarly, in software, abstraction allows programmers to focus on high-level functionality without worrying about complex internal processes. Inheritance allows one class to acquire properties and behaviors of another class. This enables code reuse and simplifies software design. For example, an animal class can be the parent of a dog class. The dog class automatically inherits the attributes and methods of the animal class, and we can add specific behaviors unique to dogs. Inheritance reduces redundancy and helps organize software hierarchically. Polymorphism means many forms. It allows the same function or method to behave differently depending on the context. For example, a teacher can also be a parent and a customer in different situations. In programming, polymorphism can be achieved through method overloading or overriding, allowing flexibility and simpler code. Advantages of Object-Oriented Programming (OOP) offers several advantages over procedural programming. First, it improves modularity, as each object is independent and can be developed separately. Second, it promotes reusability, since classes can be reused in multiple programs. Third, OOP enhances scalability, allowing software to grow without major changes to existing code. Fourth, it ensures better maintainability, because changes in one object usually don't affect others. Finally, OOP increases security, as data is encapsulated and access can be controlled through methods. OOP in modern programming languages. Most modern programming languages support object-oriented programming. C++ was one of the first popular OOP languages, followed by Java, which made OOP widely known and used. C# is another language heavily based on OOP principles. Even Python and JavaScript, which are not purely object-oriented, provide strong OOP support. These languages use classes, objects, inheritance, polymorphism, and encapsulation to build software ranging from simple applications to complex enterprise systems, web apps, mobile apps, and games. OOP versus procedural programming. To understand the power of OOP, it is helpful to compare it with procedural programming. Procedural programming focuses on functions and procedures, whereas OOP focuses on objects. Procedural code can become difficult to manage in large projects, lacks security, and is not easily reusable. In contrast, OOP organizes code into modular objects, promotes reusability, provides better security, and is easier to maintain. For large-scale software systems, OOP is almost always preferred. Real-life applications of OOP object-oriented programming is used in almost every field of software development. Banking systems, e-commerce platforms, web applications, mobile apps, games, and operating systems are all built using OOP principles. For example, in a banking system, an account class can represent different types of accounts like savings or current, and each customer's account becomes an object of that class. This approach allows developers to write clean, reusable, and maintainable code. Conclusion. In conclusion, object-oriented programming is a powerful approach to software development. By modeling real-world entities as objects and using classes, attributes, and methods, OOP allows developers to build structured, reusable, and maintainable software. The four pillars, encapsulation, abstraction, inheritance, and polymorphism, provide flexibility, security, and scalability. Mastering OOP is essential for anyone aspiring to become a proficient programmer, software developer, or engineer. Closing, call to action. Thank you for watching this detailed lecture on object-oriented programming. If you found it helpful, make sure to like, subscribe, and hit the notification bell to get updates on more in-depth programming tutorials. Share your questions or doubts in the comments, and in our upcoming videos, we will explore each OOP principle with real coding examples, so you can learn by doing. Keep practicing, keep coding, and happy learning.